Today we will be talking about the introduction about artificial neural networks from Unit 1. So let us first try to understand the basic definition of artificial neural network. Now, according to the DARPA, that is Neural Network Study in 1998, a neural network is a system which is composed of very simple processing elements which work in a parallel and coordinated and distributed manner, and where the overall function of this network or the neural network is determined by the network architecture that it is being defined with, the connections that is being existing between the various processing elements, and the processing which is performed at computing elements of the nodes. So in very short, neural network is nothing but interconnected, huge connection of processing elements which exist or which works in parallel and distributed manner. And the overall purpose is to mimic the way human solves a problem. It is basically created with the intention to put the similar kind of learning ability, the similar kind of training ability, the way human does. So as you know that humans are very good at solving the problems based on the learning. They are very good at solving the problems by learning from the examples. They are very good at finding the unknown patterns within the data of within the problems. So all these kind of ability when we try to put in through these neural networks, and that is what is the overall objective of the entire neural network as a study is. So let us first try to understand this ANN basically tries to, which I have told, that tries to mimic in the same manner which human does, human approaches towards a problem. That is learning with examples, learning through training. So ANN is also pretty like the same, where we would be putting certain examples. We would be training the system. We would be training our system so that it can learn something, and then we can provide certain new inputs, or we can provide certain new unseen things, so that ANN can able to predict, can able to decide what it has on the basis of learning. For example, if I teach my neural network to start recognizing the characters from suppose A to Z. So in the initial part, we would be giving the training pairs. That is, we would be given the inputs in terms of the characters, various characters from A to Z. And we would be also providing the associated outputs. Suppose the pictures, associated pictures, suppose A for apple, that means from A, it would be on the left-hand side. On the right-hand side, we can have a picture of apple. So the way a human or a child learns, so we would be given input and output. So once that training is done, once we feel that we have learned, then what we can do is we can just hide the output, that is the labels, and then we can give certain inputs. Those inputs can be for testing basis. It can be the same inputs that we have trained, and then if we have learned properly, then we can also handle the new inputs that we have not trained. So it is exactly the same way the human does, right? So this kind of ability, when put into systems, then we are actually talking the objectives for the neural network. The beauty about neural network is that we do not have to program it explicitly the way we solve a problem when we write algorithms. So for solving, when we write an algorithm in the classical problems, then we need to give what is the output and how the system is going to behave for each and every possible case of inputs that may be given to the system. So over here, we want that we train the system, we give limited number of inputs, and then the system should have the ability to learn, to form a kind of organization of that learning, and create its own new learning. So that kind of ability which is having with human beings. So that is what we want our neural networks to do, to learn explicitly, to learn by itself. So it can add up to the new learning. It can add up to what it has already learned. So it is almost like the way human brain works. Uh, ANN we can talk about, definitely it is a mathematical model or the computational model that is inspired by the human-like learning. So let us first understand why this we are talking about ANN, and what exactly the benefits that come from learning ANN, and the solutions which we obtain from ANN. So the primary objective, or the primary example, is that we can handle the complicated or imprecise data when we talk or when we start using ANN. Because at times there can be, like for example, if I'm processing my speech, right? So there can be a lot of issues with my data. So they can be this data can be very complicated. This data can be very huge, because when I'm going to convert this into human computer readable format, the speech can be a huge data, right? So ANN, artificial neural networks, will be very good at dealing with this complicated and huge data. They can also handle a lot of impreciseness also, although we have to put in some concept of fuzzy logic into it in that case. But they are very good at handling these kind of complicated data, which normal humans or normal human beings would not be able to do. So this is where the ANN can be pretty useful. Similarly, once we train our neural network, it can become like an expert in that particular field. So human beings do have that capability of acting as an expert, but we have a limited kind of capability. We cannot expect to learn huge or remember huge amount of information. So, but that we can do it with the artificial neural networks. We can train the networks, and we can make them to remember huge information can be made them to remember. So they can actually act an expert in a particular domain. So which are human beings have its own problems with the amount of memory we can process and the amount of memory we can take care of. This expert, which we are talking about after training, can be used as a kind of tool to provide projections with new situations of interest, and we can always ask the questions with such experts, and it is expected to provide suitable answers, which is not directly given into my input, right? The other advantages, if we sum up certain advantages of artificial neural network, so adaptive learning is one which we must look into. That is the ability to learn how to do the task based on some data which has been given to me for training. So we would be given training. So when we would be training our artificial neural network, so we have to give some data, and we have to give some data. That data can be in a manner where we can give examples. It can be patterns. So that data, once we give it for training, and with some kind of, we can also call it a kind of initial experience, right? So it should be able to learn from that data. It should be able to adapt to learning also. So that is what actually is called the adaptive learning. I should be able to adapt to what has been given to me as an input. The most beautiful part of artificial neural network is the self-organization part. That is, say, suppose if I've only taught my systems to learn from, suppose, A to, say, suppose P. I have taught only the letters, suppose A to P. So rest of the letters, if my network has been trained in a correct manner, so it should be able to adapt to the new learning also, right? It is not only whatever has been taught and whatever has been trained. It will not only react, and it will not only start giving us the solutions from that portion only. Otherwise, it would be more or less like hard-coded examples, right? So neural network does organize from whatever it has learned, which is called a self-organization of that learning. And then it can produce some new learnings out of it. And that is how the human does also. So we never rely upon what has been taught and what we have learned. We always keep on adding up to that learning based on what we have learned. That is called self-organization. So that is the most important aspect of artificial neural network. And definitely the real-time operation. We cannot expect to, suppose if I've been given a problem to solve, so I want that solution should come up in a real manner, real-time operation. So the way human does. So if I've been given a problem to solve, so we most of the time be able to solve it in a real-time operation. whatever may be the complexity of the data or whatever the hugeness of the data is. So the same kind of expectation is from neural network also. They're able to work in a very well coordinated and parallel and distributed manner. So we expect that they should be able to respond back in real-time operations. Again, one of the other very beautiful aspect of neural network is that it is fault tolerant. It is redundant, that is via the redundant information coding. That means if since we have a huge connection of the neurons, the processing elements that work in parallel. So even if some of the neurons, even if some of the processing elements doesn't work or are producing some faulty results, so it would not impact the overall. It may impact something, but it would not be a complete failure of the entire system. You can think of this like, for example, uh, if some number of people are working on a problem, suppose, and if one of the person or some of the persons are not able to work because of some reasons or suppose on holiday, so it does not mean the entire work or the entire job which we are working with would come to a halt. So it has a huge ability towards the fault tolerance. The fault tolerance is one of the basic performance criteria for neural networks. So let us first also understand what are the various type of learning this neural network can deal with, or in general, what are the various type of learnings. A very simple form of learning is supervised learning. Supervised learning means that you have someone, or we can call them a teacher, to assist you at every step. That is, we always, along with the input, we have the outputs given for training. So in supervised learning, we always does the training first, and once that training is complete, then we assume that some learning must have been achieved. And once that learning is achieved, then we can give the new inputs, and then we can, based on what we have learned from the training, we expect that the system should be able to give the correct responses corresponding to the new inputs. So supervised learning, we have the inputs and the corresponding outputs, and each and every input is labeled with an output. So we train first. So the training must be suitable enough. We will be talking about these aspects as we move on this particular subject. So how this training has to be done, on what kind of data it can be suitable to, what should be the size of the training. That is, these are various performance criteria for supervised learning. So supervised learning is something which we always do in real life also. If, by example, if I teach a student or a child the characters from A to Z, so what we do is like we present in front of that student while training, while he's learning that A for apple. So we have A, and as well as the picture of apple on the right hand side. We have left hand side we have suppose B character, and on the right hand side we have an example, suppose bat. So we keep on training the student or the child so that he can automatically understand some kind of unknown connections between the inputs and output. See, mind you, we doesn't know that how we can achieve or how we can go from input to output. Otherwise, we would have written hardcode algorithms, right? And that is why we are talking about these kind of learning. Since we are not able to devise, and since we doesn't know even the method that how we can achieve from or go from input to the output, so we can assume that there is a function from suppose input to output. That function is not known, and this function is being trained through these examples, right? So it is more or less mathematically equivalent to function approximation, the function the mapping between input and output. So once a student or a child somehow maps input to the output, we say that yes, to some extent training is complete. See, this training size or this training cannot be similar for each and every type of learners. It may differ. For a child one, we may give 10 examples and he may learn. For the other child, we may have to give suppose 100 examples before we may say that he has learned. So the number of issues with that, what would be the criteria or what would be the parameters when we would start saying that supervised learning has been done. So we'll be coming to this supervised learning later on. We will be doing specific examples under the supervised learning also. Another form of learning could be your unsupervised learning. That is, here we doesn't have the output. There are a number of times that we have the data, but we doesn't know what to do with the data. It is absolutely unknown. So these are hidden patterns. Suppose we are searching from some kind of hidden patterns. So this kind of problems can be come or can be taken into the class of called unsupervised learning. So what we do is we have the data. We try to formulate some kind of similarity or some kind of connection within the data in order to find some kind of classification, or in order to find some kind of similarity among the data. And then we say that yes, this input can be put in this kind of output, or this input can be put into some other kind of output. For example, if I've been asked to do some kind of do kind of analysis on my data, which for which I doesn't know what would be the corresponding outputs. So if I've been asked to do so, so I can find some kind of parameters, and in order to study what are the similarities between the inputs, and then accordingly I can come up with some kind of solutions for the given inputs. So again, we would be doing some kind of examples on the under the unsupervised learning also, as we keep on going in this subject. Another form of learning, although it is a form of hybrid kind of learning, which we can call it a kind of reinforcement learning. Say, in reinforcement learning, it can be thought of partly supervised and partly unsupervised learning. So some part of it acts like a supervised learning. So in supervised learning, issue could be like if we have while during the training, we may go in a wrong direction, and and once the training would be complete, we may come to know that no, the direction which was taken during the training, so that that direction was absolutely wrong. So in supervised learning, if I can keep someone in between, a kind of teacher, which says that in every point of step, whether I'm going in the right direction or not. So in a form of answers yes or no. So that would be a kind of reinforcement learning. Every time I'm reinforcing the learning and to make it in the correct direction. So this strategy is built on a kind of observation. So every time I make an observation and help the person who is learning, right? So here ANN can make a decision by observing the environment and each and every step. So that would help him to take the right direction or right path. So it is a kind of both kind of learning are involved into it, a kind of supervised and a partly a kind of unsupervised learning, right? And if the observation is negative, then the network can adjust its weight accordingly and can make a suitable shift into the direction in which it is learning. Otherwise, if it is positive, then it can make the direction in the, it can keep on moving in the right direction. So this is called reinforcement learning. Now, as we have already discussed, like neural network is nothing but the entire motivation comes from the human brain. The entire motivation comes from the huge capability that human brain possesses, which has millions of billions of nerve cells or the neurons which are working in a very connected and a very distributed and parallel manner. So if you can, this is just a kind of table which shows some kind of differences between the computing machine and the human brain. For example, the number of processing elements in brain, we would be calling it as a neuron, and here it would be called as a transistor, for example. So you can look at the difference between the kind of processing element that a human brain does process, right? So 10 to the power 14 is a huge difference between 10 to the power 8. So these are different parameters which we can that would help us to have a little bit of understanding. Like the most beautiful part is like the style of computation. And in the human brain, the style of computation is always what? Parallel and distributed. We never go in a serial fashion. The processing, human brain never processes in a very serial and serial fashion, right? Or but the systems will always work in a serial and centralized fashion. Although we can have a parallel computing environment where we can come up to the expectation of a human brain. So all this requirements and all these kind of parameters that I have compared would help you to understand that what is the difference between what are the challenges that we need to have in order to, if we want to mimic a human brain. So you just look at this huge connection of that you can find in a brain, huge connection of these neurons which are interconnected. So the entire information in the form of spikes of chemical concentration flows in these neurons. And just look at the kind of problems and look at the kind of ability that human brain possesses, and such a huge and complex network in between. So, in order to mimic, or in order to have some kind of capability the way human brain does, so we have to put, or we have to associate that kind of connections, or that kind of hugeness of connections, that kind of complexity of connections, even with the kind of parallel and distributed mechanism has to be inserted into a neural network, so that any suitable and meaningful information can be processed.